Let's finish up just one thing that I have pending from the previous chapter, which I think might be interesting for you, which is the relevance of this discussion, or the dipole discussion that we had before. We talked about the electric field of a dipole. We looked at the electric field lines produced by a dipole, right? And so if you remember, the electric field lines will go from the positive towards the negative. And remember that the dipole is characterized by the magnitude of the charge. One is going to be positive, the other one is going to be negative, right? And we said the dipole moment is equal to the charge, the magnitude of the charge, times the distance, right? Now, another thing that we can look at the dipole is the dipole potential. What are the equipotential lines generated by two charges, one positive, one negative? So, if you think about it, you realize that the line that goes through the middle of the dipole is the line with potential equals 0. Right? Because if you're at one point, standing at one point here, the contribution from one charge is k q over r, and the contribution from the other charge is minus k q over r, which obviously gives you a 0. So there is an equipotential line that bisects the dipole. Then there's other equipotential lines going around like this. If you are on top of this line, of the potential equals 0 line, you're moving towards higher ground, right? Thinking about the analogy with a landscape, you're going uphill towards the positive charge, which is like an infinite mountain, right, in this landscape. So this is positive potential over here. And if you move down here towards the negative charge, then you're moving towards points with negative potential, right? And if you were to move all the way to the negative, to the center of the negative charge, suppose that it's a point charge, then the potential will be minus infinity, right? Now, what is the relevance to this, for example, medicine? Can you think of an application of, or can you think of a place in the human body where there might be a dipole? The heart. The heart is a dipole. Why is it a dipole? What's about the heart that has some current or some charge? And go ahead. The neurons and the muscles in the body, in any animal tissue, in any animal, they have a lot of electrical properties. Both the neurons and the muscle. The muscle fibers are actually very similar in the way they work in terms of electricity, in the way they work with electric charges and ions going in and going out and so on. So the muscle, the fibers in the heart, when they contract, they receive an electrical impulse, right? And when they contract, the contraction occurs when the fiber receives one of these pulses, one of these electrical pulses, which is polarization and repolarization pulses, that changes the polarity, that changes the concentration of ions on both sides of the membrane of the cell. So actually, if you were to measure the potential of one of the cells in a muscle, and in particular in the heart, you will find that it's a little dipole. That one part of the cell is more positive than the other part. Okay? So if you put all of these dipoles together, you end up with a significant dipole, some dipole that can be measured by placing electrodes on the body, on the skin of the body. So what happens is that as the muscles of the heart are contracting, those dipoles are oriented in one way or the other way, depending on which part of the heart needs to contract, right? And that changes the electric potential on the skin and produces little currents all over your skin and in your body, because you are basically a conductor. So those changes in potential can be measured with electrodes, and you can actually measure them very precisely in many different locations on the torso, for example, and maybe other places in the body. And you can actually make a plot of the electric dipole of the heart as it is changing in time. It changes in time by by changing direction and by changing magnitude. And you can do a plot of this dipole that moves around in space with a particular trajectory in space. And by analyzing this, it's called a vector electrocardiogram, you can tell a lot of things about the working of the heart. If there has been a small damage to the heart in any region, then those muscle fibers are not contracting the way they should be, which means that the dipole, when it gets to that region, the dipole gets smaller than it should be. A lot of analysis can be done by doing these kind of measurements of the electric potential on the skin.